Everyone cheered when 3i Atlas got the all clear, yet something closer slipped through the sun's glare and is rushing toward a much tighter pass. Days, not months, remain. If you want the real story beyond the headlines, stay with me. Here is the paradox. The exotic interstellar traveler hogged the spotlight while a quieter visitor ghosted along the edge of visibility, revealing itself only when the sun finally blinked and gave it away. The calendar reads mid-October. On October 20th, this newcomer makes its closest pass by Earth. Not a collision course, not doomsday, but close enough to demand our attention, because we discovered it late, and we still do not know how stable it truly is. You are about to meet Comet C 2025, R2 Swan, the comet almost everyone ignored until it was practically on top of us. It is not famous. It is not interstellar. It is simply inconvenient, and inconvenient is the kind that tests our systems. We did not spot it with the usual wide-field optical surveys that sweep the night for faint moving dots. An amateur analyst trawling spacecraft data saw a different kind of glow, hydrogen light in the ultraviolet. That clue appeared because the comet had already swung around the Sunday. We started the movie halfway through. Why does that matter? Because timing is everything in orbital work. When you begin late, the math has to stretch farther to fill the gaps, and small pushes from venting gas can nudge a light body more than you expect. We do have comforting numbers. The closest approach distance is on the order of tens of millions of kilometers, roughly 100 times the distance to the moon. That sounds large in human terms, and it is. In cosmic terms, it is a near miss. A miss all the same, but with lessons attached. Look at how it behaved. In late September, the comet brightened suddenly. Astronomers call that an outburst, the moment when trapped ices meet heat, crack, and flash more material into space. Under ultraviolet light, the envelope around the hidden core glowed green, a chemistry signature that says carbon-based molecules are lighting up. None of that is alien. It is textbook comet physics. Yet those same features hint at a fragile body with patchy vents and shifting jets. Fragile objects sometimes shed pieces, and pieces do not always follow the parent like obedient children. Here is the bigger idea. The true risk was never the spectacular object in the news cycle. It was the one our eyes could not easily see. There is a blind zone near the sun where ground telescopes refuse to look, for good reason. Place a fast-moving target in that glare, and your instruments fall silent. Put a hydrogen imager in space, and the ghost appears. That is how this story began. With a glow most of us will never glimpse directly, and with a clock already ticking toward a date you can mark on a wall calendar. So no, this is not panic. This is perspective. We will translate every intimidating number into speakable, human-scale distance and time, then ask what those numbers leave out. We will separate spectacle from signal and sift for the part that actually matters to satellites, to astronauts, and to anyone who likes a quiet sky. Along the way, you will see why late discovery is the point, why the geometry near the sun is the villain, and why the simplest green halo can tell us more than 1,000 dramatic headlines. Stay with me as we pull apart the distraction, follow the quiet comet that almost slipped the net, and learn how to read a sky that is busier than it looks. The story is not fear, the story is attention. And attention, used well, is how we keep wonder without losing sleep. 3i Atlas sounds thrilling, interstellar, rare, mysterious. Words like that light up our brains, but distance and geometry are boring heroes, and they are exactly why this visitor is not a threat. Start with scale. Astronomical unit means the average distance from Earth to the Sunday. When we say 3i Atlas will pass at about 1.8 astronomical units from Earth, we mean it will be roughly 167 million kilometers away. Picture the moon at about 400,000 kilometers. Now stack that distance more than 400 times. That is the gap. In a solar system built on gravity, that is not a near miss. That is a polite wave from across the neighborhood. Trajectory matters too. The path of 3i Atlas is inclined and well separated from the lanes we travel. Orbit solvers have had time to refine its elements because it was found early, tracked often, and bright enough to follow without guesswork. Observations across many nights shrink uncertainty. Error bars do not vanish, but they get small. The result is a calm forecast. Enjoy the spectacle. Sleep fine. So why the noise? Interstellar captures imagination the way few words can. We have only seen a tiny handful of wanderers from beyond our sun's family. When a true outsider arrives, novelty takes over. Newsrooms love novelty. Social feeds love it even more. The story multiplies, and the numbers fade into the background. Distance becomes an afterthought. The mind hears from another star and quietly translates it to closer than usual. It is the opposite. There is a second reason the story runs hot. Our first famous interstellar visitor rewrote expectations and sparked years of debate. That memory lingers. When a new outsider appears, people imagine surprises and hidden maneuvers. The reality is steadier. Most objects obey the same rules. Gravity rules the dance. If there are small pushes from outgassing, they show up as gentle drifts that precise measurements can see and fit. Nothing in the current data suggests a sudden swerve toward trouble. Here is a practical way to hold it in your head. If you could build a perfect line between the Earth and the comet at closest approach, you would not see texture on the comet. You would not see a surface. You would barely see a point. That is how far it is. The scale itself keeps you safe. Now, pivot your attention back to what truly matters. Big headlines do not equal big risk. Quiet object discovered late can be more interesting from a safety point of view than a loud object discovered months ago with a comfortable miss. 3i Atlas earns awe and curiosity. It does not earn anxiety. Turn the energy you feel toward the investigation that needs it more. The comet hiding in the sun's glare, the one we saw only after the brightest part of its loop, teaches us something about our blind spots that a distant interstellar flyby cannot. This is how we keep the pulse steady. Celebrate the wonder without letting adjectives steer the ship. Ask for distances you can compare to the moon. Ask for how long we have tracked the object. Ask how many independent observations support the orbit. When the answers line up like they do here, the proper response is simple. Smile, admire, move on, and then focus on the comet we almost missed. Before we chase fears, let us meet the actual traveller. C2025R. 2 Swan is not a celebrity comet. It is a working example of how discovery really happens when the sky and our tools are not cooperating. Its first footprint was not a pretty photograph. It was a whisper of hydrogen light that most of us cannot see with our eyes. A spacecraft called the Solar and Heliospheric Observatory carries a sensor named SWAN, short for Solar Wind Anisotropies. Instead of photographing stars in visible light, SWAN maps the glow from hydrogen atoms at a specific ultraviolet wavelength. Comets breathe water vapor when the sun warms them. Sunlight breaks that vapor into hydrogen and oxygen, and the hydrogen billows outward into a huge cloud that can be easier to spot than the comet itself. That is the trick here. While ground-based surveys were blinded by the sun's glare, the hydrogen glow made the ghost visible from space. An amateur analyst who knows where to look began scanning SWAN frames from early September and noticed a faint blob sliding from one position to the next across multiple days. That motion mattered. The point was not a single bright pixel. The point was a persistent shift that matched the cadence of an object orbiting the Sunday. The report rippled outward through the community. Telescopes on the ground spun to the coordinates during the brief pre-dawn windows when the sun sat just far enough below the horizon to give a sliver of dark. The optical view confirmed it. There was a fuzzy patch with a small tail, the classic sign of a live comet. By the time the optical crowd caught up, the comet had already passed its closest point to the sun in mid-September. That lost act matters. The weeks before and after perihelion are when small icy bodies often change character. Heat cracks surfaces, vents open, dust breaks free. If a fragment split off then, we missed the moment. We are watching for echoes now, not the event itself. We can still draw a clean sketch. The sun sits at the center. Earth orbits at a distance of about 150 million kilometers. R2 Swan swooped inside the path of Earth, swung around the sun at roughly 75 million kilometers, then began to climb outward on a long arc that crosses near our lane. On October 20th, it will be closest to Earth at a distance near 39 million kilometers. That is far in human terms, and safely so. It is still close enough that we care about behavior, because behavior can change the fine details. What does the comet look like through small telescopes? Not a cinematic snowball, more like a dim cotton puff with a soft core that resists sharp focus. Around that core, a greenish haze often shows up in long exposures. That color is the signature of carbon-based molecules energized by ultraviolet light. Sometimes thin streamers bloom away from the sun, narrow jets that reveal a surface that is not uniform. As the body rotates, different vents face the light and send material outward in different directions. Think of a garden sprinkler that spins slowly and spits in bursts. Here is why that matters for the story. A nucleus with patchy jets is like a boat with tiny side thrusters. Each vent is a weak push. Over days and weeks, those pushes add up to gentle nudges that orbit solvers must estimate and subtract. The main path remains a miss. The nudges can still shuffle dust and pebble-sized debris into a wider ribbon along the track. If Earth crosses a denser patch of that ribbon later, we might notice more meteors or see satellite operators tilt solar panels to present less area for a few hours. It is not apocalypse. It is housekeeping in space. C 2025. R2. Swan is therefore two stories at once. It is a harmless flyby in distance. It is also a late arriving lesson about how our best machines can miss what glows right next to the Sunday. The glow that gave it away lives in a colour our eyes cannot see, the kind of colour a spacecraft is built to notice. That is why this quiet comet matters. It is a case study in humility, a reminder that the universe rewards patient observers who keep checking the corners that light up last. If you want to hide a moving object from most of our telescopes, you do not need stealth technology. You just park it near the sun in the sky. That is the cheat code. The brightest thing we can see turns the air into milk and saturates sensors. Even the best ground instruments refuse to stare too close to that glare. They must look away or risk cooking delicate detectors and drowning in scattered light. Picture the geometry. Draw the sun at center stage, then place Earth off to one side. Now, imagine a narrow cone around the sun from our point of view where daylight and twilight spill across the optics. Objects that skim that cone are effectively invisible to most night surveys. Their light is swamped. The atmosphere throws halos and flares into the images. Automated pipelines, which expect crisp stars against dark backgrounds, choke on this messy gradient and quietly discard the frames. The result is a real, well-known blind zone right where fast newcomers often appear. So how did we see what the night side could not? We cheated in a smarter way. The Solar and Heliospheric Observatory carries instruments built to live with sunlight. One of them watches a specific color of ultraviolet light that hydrogen atoms emit. Comets breathe water vapor when the sun warms them. Sunlight breaks that vapor apart and a huge cloud of hydrogen swells around the nucleus, far larger than the greenish coma you might glimpse in a photograph. That hydrogen cloud is a lighthouse in ultraviolet. To a sensor tuned to that color, a hidden comet draws its name in neon across the solar glare. This is why the first clue for R2 Swan was not a pretty visible image, but a slow, patient animation of ultraviolet frames. Dot here, dot there, dot somewhere else tomorrow. Shift by shift, the motion betrayed an orbiting body. Only then did ground telescopes get a brief chance to catch it in the sliver of dark before sunrise. We were late to the show, through no one's fault. The stage lights were simply too bright. Starting late has consequences. Orbits are not carved in stone. They are estimates that sharpen as fresh positions arrive. With a comet, small jets act like tiny thrusters. Over days, those pushes add up to gentle changes in the path. If you have months of data, you can measure and model those pushes. If you jump in halfway, you must assume more and extrapolate farther. The difference is not panic. It is uncertainty, and uncertainty is a tax you pay with time. When the calendar says days until closest approach, that tax stings. Here is the productive part of the story. The blind spot is a limitation, not a scandal. Scientists mapped it years ago. Mission designers built tools to peek into it from space. The system works when all pieces line up. But limitations become risk when the timeline compresses. A comet that emerges from glare in mid-September and swings near our lane in mid-October gives you very few nights to lock down the fine print. So we treat sunward discoveries with a different posture. We expect fewer early images. We expect larger error bars at first. We watch more closely for outbursts that could tweak the trajectory within that uncertainty. And we push for more instruments that can watch near the sun in multiple colors, from space, around the clock, because the sky will keep using the same trick. It will keep sliding surprises along the edge of the light, where our habits are weakest. That is the blind spot. Not a mystery, a geometry problem. Solve the geometry, and the fear drains away, replaced by work we know how to do. Measure, model, update, repeat, and start earlier next time by watching the light that most of us cannot see. When a quiet comet suddenly brightens as if someone flicked a switch, that is an outburst. Think of sunlight creeping into a crack, warming buried ice, and turning it straight into gas. Pressure builds. A patch opens. The comet exhales. In minutes or hours, the cloud around the hidden core swells, and a dim smudge becomes a noticeable presence. Late September brought exactly that kind of lurch for this visitor. Reports from observers described a jump in brightness and a quick expansion of the fuzzy envelope that surrounds the nucleus. That envelope has a name, the coma, And it is not empty. It is a drifting cocktail of water vapor, carbon compounds, and fine dust grains cast off from the surface. When the coma thickens, the comet looks bigger, but the solid heart remains buried and unresolved to small telescopes. We are watching the breath, not the body. The strangest and most beautiful clue is the color. Long exposures reveal a soft green wash near the core, then a paler haze fading into the tail. That green is a fingerprint. Diatomic carbon and cyanogen molecules get energized by ultraviolet sunlight and then glow in the visible range our eyes can see with the help of a camera. It looks alien. It is not. It is ordinary chemistry playing out in a very cold, very dark vacuum that only seems theatrical because the stage is so black. Outbursts often ride with jets. Imagine the nucleus as a lumpy worldlet turning slowly. One face is richer in volatile ices than another. As it rotates, fresh patches wake up under morning sunlight and vent like tiny geysers. Each jet is a weak thruster. Over hours, the direction of that thrust sweeps as the body turns, and the tail records the choreography as narrow streamers and subtle kinks. From night to night, you can sometimes see the tail reshape itself, a slow language written in dust. Dust grains matter more than most people think. The smallest grains get pushed hard by sunlight and flee outward, building the classic curved tail. Larger grains are heavier and more stubborn. They lag near the nucleus and thicken the inner coma, creating a chalkier glow that fades slowly. If a comet begins producing many larger grains, we start to wonder whether the surface is flaking and whether weak crust is peeling into clumps. Now, we are not only talking about brightness, we are talking about structure. Here is where behavior meets risk without melodrama. The main nucleus is on a miss. That is the calm fact. But a fragile nucleus can shed pebbles or even fist-sized fragments during or after an outburst. Those pieces drift along the path, each with a slightly different speed from the gentle shove of gas. Over days and weeks, they spread into a loose ribbon. If Earth later intersects a denser thread of that ribbon, we notice as a bump in meteor counts, or as a modest uptick in micrometeoroid hits on satellites. Operators can respond by slewing a spacecraft to narrow its profile for a short window. Housekeeping, not catastrophe. So, what should we watch for? Next, another sudden brightening would hint that fresh vents opened, or a crack grew wider. A change in the shape of the tail could reveal new jets turning on or off. A persistent haze of heavier dust would suggest the surface is crumbling more than usual. None of these signs mean doom. They are diagnostics. They tell us how lively the engine inside the ice really is, and how much material it is adding to the river already flowing along its track. In short, the green halo is a chemistry lamp, the jets are the steering whispers, and the outbursts are the loud coughs between quiet breaths. Listen for all three, and the comet begins to speak. Numbers first, then feelings. The path of this comet is a stretched ellipse so close to a parabola that it almost never returns. It dived inward, brushed past the sun in mid-September at roughly 75 million kilometers, then bent outward toward a point where its trail and our lane pass near each other. That near is doing a lot of work. Closest approach to Earth is on the order of 39 million kilometers. Think of the Moon at about 400,000 kilometers. Now stack that distance around 100 times. That is the gap at closest pass. It is enormous for humans and machines. It is modest for a solar system, where worlds swirl in orbits measured in hundreds of millions of kilometers. In both frames, it is a miss. Here is the second number people confuse. The smallest geometric separation between the two orbital paths is about 7 million kilometers. That is not where the comet will be on the same day as Earth. It is the minimum crossing gap if you drew the two rings in space and measured the nearest strands. The timing does not line up this year, which is why the real pass is many times farther than that. The smaller number is still useful. It tells us the architecture of the freeway on which both objects travel. If the timing were unlucky in a different year, the distance could shrink. This year, it does not. Speed helps your intuition. Near-Earth distance from the Sun, our planet travels around 30 kilometers per second. A long-period comet moves tens of kilometers per second as well. Faster near the Sun, slower far away, following the same gravity that keeps us in our lane. At those speeds, tiny pushes matter. A vent that exhales gas for hours acts like a whispering thruster. Over days, these whispers sum to gentle nudges that shift the path by small amounts. Orbit solvers fold those non-gravitational effects into the math, then update as fresh positions arrive. Uncertainty is not a monster, it is a range. Early after discovery, the range is wider, because the arc of observation is short. Add more nights, and the range narrows. For this pass, the range is already tight enough to rule out impact. That is the statement that matters for anyone sleeping under the sky. The rest is fine print for operators and modelers. What about brightness predictions? They are not promises. A comet brightens as sunlight digs into fresh ice, then fades as the geometry changes and the venting slows. Outbursts can jump the curve. Fading can disappoint stargazers who expect a show every night. Brightness does not drive the risk for this case. Geometry does. The geometry says pass, not hit. You can translate these numbers into one mental picture. Place the sun at the center of a giant clock. Earth is a minute hand sweeping a steady circle. The comet is a long needle that swoops in, swings through near the sun, and shoots outward again. The two hands cross the same part of the clock face at different times. No collision, no near scrape. Just two travelers sharing a freeway with good lane discipline. There is still work to do because that is what professionals do. Keep measuring positions to watch for any small drift. Try for high-resolution images to check for fragments. Monitor meteor cameras for a subtle uptick in dust later in the season. None of those jobs change. The headline. They refine it. The numbers are not trying to scare you. They are trying to tell you a calm story. Big miss, clear lane, interesting behavior worth watching. We can hold all of that at once without turning wonder into worry. October puts on a sky show whether you asked for it or not. Two comets share the stage in northern nights, while the Orionid meteors sprinkle fast silver lines from the direction of Orion just before dawn. Beauty is not the problem. Beauty is the distraction. When the sky turns theatrical, the timeline for careful measurements gets squeezed. Here is the setup for a perfect split-screen evening. One side is the human experience. A backyard, a jacket, a pair of binoculars. You face the darker half of the sky and look low along the eastern or northeastern horizon before sunrise, where a faint cotton puff hangs above the glow. That will be the newcomer, subtle and ghostly. The other side is the professional grind. Telescopes racing the clock between the end of twilight and the rising sun, squeezing in exposures, calibrations, and follow-ups while the air is steady and the comet is just far enough from the glare to stand out. Add the annual Orionid meteor shower, and you get a crowded calendar. The meteors come from dust that Halley left behind long ago. Earth cuts through that river every year around this week. On a good night, you might count a steady handful per hour from a dark place. That baseline will happen regardless of our newcomer. The question the pros will watch quietly is whether the count bumps a little higher than usual later in the season. If that happens, it is a clue about dust, not doom. Crowded skies are wonderful for public interest. Phones point up, photos of soft green comas and short tails land on social feeds, threads bloom with tips and sightings. That attention is useful when it leans toward curiosity and patience. It turns brittle when a dim night becomes a broken promise and people chase a spectacle every evening, as if comets owe us a performance. They do not. They breathe, cough, and drift on their own schedule. Some nights they underwhelm, some nights they surprise. Meanwhile, the real work continues in quiet. Each night that offers even a 30-minute window near the horizon is a chance to pin down the position a little better and shrink the uncertainty a little more. High-resolution images try to sharpen the inner coma. If a tiny fragment has split and moved a few hundred kilometers from the core, a lucky run of seeing might just tease out an elongation. Radar teams check geometry to see whether a ping is possible. Meteor networks compare fireball rates and speeds. Every result feeds the same goal. Confirm the boring headline and record the details for the archive. Here is how you can enjoy the show without feeding the distraction. Set expectations low on brightness. Treat any visible tail as a gift. If you share images, share the basic facts with them. Date, time, direction, elevation, a 1 or 2 sentence note about conditions, thin cloud, haze, city lights. That context turns a pretty picture into a tiny data point others can use. If you keep a journal, even better. Honest notes beat dramatic adjectives. The sky can delight and educate at the same time. This month does both. Enjoy the Orionids. Hunt the dim cotton puff if you like a challenge, then give a nod to the telescopes racing the sunward edge before breakfast. Their work is the difference between spectacle and safety, and it depends on nights exactly like these. Sometimes the most honest headline would be 3 words. We were late. The sky moves whether we look or not, and small fast objects do not wait for us to finish dinner. They arrive out of the bright zone near the sun or up from the southern horizon, where few big telescopes point, flash across a strip of sky, and are gone before most of us knew there was anything to see. A handful of recent flybys taught this lesson with embarrassing clarity. Tiny asteroids only a few meters wide slipped inside the orbital highways where our satellites cruise. One skimmed closer than many platforms that carry weather cameras and communication antennas. That sounds terrifying until you remember scale. A rock the size of a van burns up in the upper atmosphere. It becomes a fireball, a sonic thump, a story told by early risers. But the physics that makes small visitors harmless is the same physics that would make a larger surprise much harder to manage if we met it late. Why do late discoveries happen in a world of smart surveys and automated pipelines? Geometry first. An object approaching from the direction of the sun is hidden by glare until the last hours before closest pass. Speed next. A fast mover does not linger where our scanning patterns expect it. It crosses a field in minutes, not hours. Then, there is surface. Dark material returns little sunlight and hides against a sky that is never perfectly black. Add clouds, maintenance downtime, and the simple truth that the entire planet does not own one synchronized telescope, and you have gaps that clever rocks can slip through without meaning to. Here is where you face the unpleasant arithmetic of options. Early discovery buys choices. Weeks or months of warning let you schedule radar, book time on big mirrors, model the orbit with care, and if needed, quietly ask satellite operators to plan protective modes for a particular hour. Hours of warning do not offer the same menu. At that point, you're in test mode, not prevention mode. You collect what you can, inform who you can, and watch the sky write the ending. Late is not always a failure of people. It is a failure mode of the system that everyone who works in this field knows by heart. That is why the response looks calm, even when social feeds run hot. The checklists are boring. Cross-match survey reports. Task a second instrument to confirm position and motion. Push an orbit. Update. Share a short note with the networks that monitor fireballs and satellite health. If nothing else is possible, do not invent drama to fill the gap. The cameras will tell you what happened in the morning. Learning too late leaves marks. Sometimes it is a bright dash on a wide-angle meteor camera. Sometimes it is a small increase in micrometeoroid hits on a solar panel. Sometimes it is nothing at all but a better estimate of how often we miss that size of object. The lesson is not that doom lurks, it is that vigilance must live where convenience does not. Near the Sunday, near the horizon, in the awkward slivers of time around dawn and dusk that professional observers fight to use. So we keep building a culture that accepts late as a signal to improve, not a reason to shout. We tune scanning patterns, we coordinate handoffs between hemispheres, we build more eyes that can stare into glare. Each small fix buys minutes or hours. In space safety, minutes or hours are the difference between guessing and knowing. Most people picture danger as a single object aimed like an arrow. Comets rarely work that way. They behave more like a shotgun that scatters pellets across space. A fragile nucleus warms, vents, cracks, and sometimes splits. What leaves the surface is not just gas. It is dust, pebbles, and on bad days, fist-sized chunks. None of that needs to strike Earth to matter. It only needs to be in the wrong place when we cross the lane. Start with the mechanics. Imagine a lumpy ice and rock world barely held together by its own weak gravity. Sunlight reaches a stressed patch, and the ice is turned to gas. That gas must escape. It pushes on the surrounding material and can lever off slabs like scabs lifting from skin. The slab does not leap away at dramatic speed. It drifts with a nudge, a meter per second here, a few meters per second there. In the early hours, it hugs the parent. Over days, the separation grows. A ribbon of siblings begins to form along the path. Dust is the constant background. The smallest grains are so light that sunlight itself shoves them hard. They sweep into a graceful, curved tail. Larger grains do not flee so quickly. They loiter near the core and trail behind, thickening the inner haze. These larger grains are the ones that make spacecraft operators frown. A grain the size of coarse sand moving at tens of kilometers per second is not sand anymore. It is a tiny bullet, and a solar panel is a poor shield. Then come the true fragments. A piece the size of a grapefruit or a backpack will not survive entry through Earth's atmosphere. It will blaze and break, feeding the sky with a bright fireball that you might remember forever. But before any piece touches air, it spends weeks or months sharing the lane with satellites. Most of space is empty. The odds are still low. Yet risk in orbit is a multiplication game. Thousands of targets, years of exposure, and a cloud of extra debris can raise the chance of a hit enough to be worth planning for. This is where the numbers from earlier Meet the scattergun picture. The main nucleus passes at around 39 million kilometers. That is safe. The minimum architectural gap between the comet's lane and ours is around 7 million kilometers. Also not today's problem. But a dust stream does not honor a single line. It is a ribbon with width and texture. If outbursts continue, if jets keep venting from different faces as the body rotates, the ribbon thickens and gains structure. Earth might later clip a wispy edge of that ribbon months after the pretty photos are gone. What would that look like from the ground? You would not see gravel falling. You would see a modest rise in meteors. Perhaps the usual autumn shower adds a few more streaks per hour. Perhaps cameras catalogue a bump in faint meteors with the right incoming speed to match the comet's lane. At most, you might hear that operators reoriented a handful of satellites for a brief window to slim their profiles. Housekeeping, not heroics. So what should we watch for now? Signs of surface weakness matter. A persistent, chalky inner haze implies larger grains. Repeated outbursts separated by quiet days hint at a crust that keeps sealing and breaking. Changes in the tail's fine structure can betray new jets and new directions of push. High-resolution images that show any elongation near the core would be the most telling clue of all, suggesting a small companion piece beginning to walk away. It helps to retire the single bullet picture. Think instead of a long, slow spray. Most of the spray misses everything forever. A little bit does not. Our job is not to fear the sky. It is to measure the spray, model where it will drift, and quietly prepare the hardware that depends on a calm vacuum. That is how a scattergun becomes a manageable nuisance rather than a surprise. When 4 headline objects arrive within a handful of years, it is tempting to whisper the universe is getting busier. Maybe it is. Maybe it just looks that way because our eyes got sharper. Pattern or perception. That is the puzzle. Start with what changed on our side. 2 decades ago, the sky was stitched together by fewer wide-field surveys and a smaller army of amateurs. Today, automated telescopes scan enormous slices of darkness every clear night. Software links faint dots across frames. Citizen analysts comb public spacecraft archives from laptops. Detection volume exploded because the pipeline matured. When you finally turn on enough cameras, the world looks more crowded. Often, it always was. Now consider the physics side. There are plausible ways the real traffic could rise for a while. A distant stellar brush long ago can shake the far reservoir of comets and send a slow wave inward that takes thousands of years to ripple through. Galactic tides can nudge orbits at the edge of the sun's domain. Those ideas are not fantasies. They are sober mechanics playing out on timescales longer than human careers. If such a wave is arriving, we would expect a gentle, decades-long lift in long-period visitors, not a sudden jump that fits neatly into a news cycle. There is also the coin flip truth. Random events clump. Throw 100 stones into a pond and the ripples sometimes arrive together in one corner by chance. 4 notable visitors in 8 years can be a streak without meaning. Our brains hate that answer because it denies story, but statistics do not care whether we wanted a plot twist. How do we tell which explanation is nearest the truth? We keep counting, and we control for our own upgrades. If a new survey with better sensitivity goes online, we expect a bump that has nothing to do with the heavens and everything to do with the instrument. If a lull follows because a telescope is down for maintenance, the sky did not calm, we just blinked. Only by tracking the health and depth of our searches alongside the raw counts can we tease out a genuine signal of changing space traffic. Here is the part that keeps humility in the room. Some of the recent headline visitors were simply odd in ways that earned attention. One tumbled and brightened in a way that did not fit our favourite models. Another was interstellar, and therefore guaranteed to fascinate. Neither oddity requires a busier universe. They require a universe that is large enough to contain a wide range of behaviours and a detection network finely good enough to notice the outliers. So what should you carry forward? Resist the itch to declare a new era on the basis of a handful of anecdotes. Celebrate the growth of our eyes, both robotic and human. Accept that streaks happen. And keep pressing for the kind of transparency that lets everyone see the denominator as well as the numerator. How many hours were actually searched? How deep did we look? How many square degrees were covered? Those are the unglamorous questions that turn a hunch into a finding. If there is a real rise, the next decade will show it cleanly, as instruments continue to watch with steady depth and cadence. If not, the counts will drift back toward the average as the streak fades. Either way, we win. More eyes mean fewer surprises. Fewer surprises mean quieter headlines and better sleep under a busy but well-understood sky. Between the discovery and the headline, there is a long hallway most viewers never walk. It is quiet there, careful, methodical. An observer logs a position and a brightness. Another team on another mountain confirms it. Only then does the object enter the ledger that runs the solar system's traffic report. At the center of this hallway sits a clearinghouse run by the international community. It gathers reports from all over the world, checks for mistakes, and posts provisional notices when a newcomer appears to be real. Provisional means humble. A handful of points on the sky are enough to sketch an early path, but not enough to swear by it. More points tighten the sketch. Each additional night is a new knot in the curve that holds the future still. Down the hall, a second group runs a service that turns those positions into full trajectories. They do not wave wands. They take the timings, the angles, and the brightness estimates and solve for the orbit that best fits the whole set. If the object breathes gas and drifts, they fold that into the calculation. When fresh measurements arrive, they rerun the math, and the path sharpens again. Curves become corridors become lanes. There is also the risk desk. Its job is not to scare people. Its job is to test whether any corridor passes close enough to Earth to deserve extra attention. Close enough is a technical phrase. It does not mean headlines or doom. It means the geometry alone could allow a future approach inside a wide safety box if the timing ever lined up. That test is automated. If a candidate ticks the box, the note moves quickly to the people whose schedule follow. Up, cameras move, dishes listen, the quiet machine hums. All of this takes time for reasons that are boring and wise. 1 observation can be a glitch, 2 can be a coincidence. 3 begins to sing a tune. You want many tunes from many instruments before you publish a song that says where and when the object will be. That caution looks like silence from the outside. From the inside, it feels like discipline. Publish too soon and you send people chasing ghosts. Publish too late, and you lose a night that could have shrunk the uncertainty by half. The hallway exists to balance those 2 failures. When the system works, most discoveries never make the evening news. A safe path stays a line in a database and a memory on a hard drive. That is not secrecy. That is triage. Headlines belong to what changes behavior on the ground. A comet 39 million kilometers away changes very little in daily life. A few enthusiasts point binoculars. A few teams test new software against real data. The rest of us sleep. The trouble begins when the quiet looks like hiding. If you do not show your work, rumor will do it for you. That is why many in the field now push for friendlier windows into the hallway. Not noise, not raw data dumps that confuse more than they clarify. Dashboards that translate the corridor into a simple picture and a sentence in plain language. Path updated today. Missed distance still large. Uncertainty shrinking. Next check tomorrow morning. Transparency does not mean skipping the patient steps. It means letting people watch them without needing a graduate seminar. When the public can see the path evolve in small daily nudges, fear has less room to grow, and conspiracy has less room to breathe. The payoff is cultural, not only technical. Trust takes root when the process is visible, so we keep the hallway quiet but not closed. We keep the math careful and the messages clear. We let the databases speak in human terms, while the machines do their tireless work. The result is not drama. It is confidence earned the slow way, 1 position, 1 update, 1 unremarkable night at a time. When strange things move through the sky, imagination runs faster than mathematics. That is not a flaw in people. It is how storytelling works. The task now is to give the story a fair trial without letting it run the courtroom. Begin with the popular claim that the comet is artificial. If a machine were wearing a comet costume, we would expect fingerprints that nature rarely leaves. Spectra would show unfamiliar ingredients or odd ratios. The brightness pattern would change in ways that point to engines rather than sunlight on gas and dust. Radio searchers might hear a carrier tone. So far, the light is the light of ordinary chemistry. The motion is gravity with small nudges from venting, and the airwaves are quiet. Could a clever civilization hide all signatures? In principle, yes. In practice, the simplest answer remains the best. It behaves like a comet because it is a comet. Next comes the suspicion that images are being buried. Some data does remain with observing teams while they process and calibrate. That is normal and usually short, but astronomy has grown into a worldwide village. Professionals and amateurs post nightly. Different countries, different instruments, different agendas. If a dramatic image existed, it would leak in hours, not weeks. The most likely reason you have not seen a jaw-dropping picture is not suppression. It is that the object is a soft puff of light near the horizon that challenges even good optics. Another story says the path is being steered. Natural steering does happen. Outgassing is a real thruster, and modelers include it because they must. The key is that these pushes produce smooth, measurable drifts that line up with the direction of sunlight and the pattern of jets. They do not look like secret course corrections. If the comet executed sharp, surprising moves that models could not fit with gas, physics, the math itself would flag the anomaly, and telescopes would pounce. The path so far remains a fit. There is also the poetic claim that a harmless path still carries a message. That belongs to meaning, not mechanics. People have always read omens in the sky. Science neither proves nor disproves personal meaning. Science asks only what the photons and positions say. On that question, the message is clear. Miss now. Watch anyway. One scenario does deserve extra attention because it is both plausible and consequential. Fragmentation and debris. Every outburst is a chance for something to crack. Every jet is a tiny push that can separate a small piece from the parent. Dust spreads along the lane. Earth can later intersect that dust and notice a faint rise in meteors or a small uptick in tiny hits on satellites. No fear required, just preparation and measurement. So the sorting rule is simple. Demand clues that match the claim. If the claim requires a chemistry fingerprint, ask for the spectrum. If it requires a jumpy path, ask for the residuals after the orbit fit. If it requires a global cover-up, ask why astronomers who disagree about everything else would suddenly agree to stay silent. Most stories collapse under that gentle weight. The few that remain are the ones worth our time. Curiosity should not be shamed, it should be trained. The universe is allowed to be weird. We are allowed to ask wild questions. Then we check. If the check says ordinary comet, we celebrate the ordinary because ordinary made it across the deep, cold, and into our morning sky. If the check says fragments, we record them, model them, and nudge the satellites into a slimmer pose for a few hours. Wonder and discipline can share the same breath. Somewhere, right now, a bank of computers is staring at the night for us. They never blink. They sift thousands of fresh images while the coffee cools on a control room desk. Their job is not romance. It is pattern hunting. At a scale, no human can survive. Here is how they work when the sky is generous. A wide-field survey sweeps a patch of darkness and grabs a series of short exposures. The software picks out every point of light, measures how bright it is, and compares the measurements with a map of the static sky. Anything that moves between frames gets a flag. Anything that brightens or fades in a way that matches known behavior gets a tag. The machine writes a tiny report card and passes it down the line. Then the hard part begins. A moving dot tracked across a few frames is not yet a path. The system must connect that dot with the same dot in earlier nights or later nights to learn whether it is a satellite glint, an airplane artifact, a cosmic ray smudge, or something real that orbits the Sunday. The robot proposes links. Humans review the strangest ones. Most die in triage. A few survive and earn telescope time for confirmation. If this sounds clean and efficient, it is only half the truth. Machines are fast but dumb in very specific ways. They learn from what we feed them. If most of the training images came from clear air and dark skies, the model will flinch when thin clouds add streaks and halos. If the catalogue of past objects is dominated by well-behaved asteroids discovered far from the sun, the model will be suspicious of a slow, messy, glow-hugging dawn. Bias is not a moral failure here. It is a statistical shadow. To get better, the robot needs more examples of the rare and inconvenient cases we care most about. Alert fatigue is the next trap. Make the system sensitive enough to catch the unusual, and you also invite a flood of maybes that drown humans in busy work. Tighten the rules to ease the flood, and you miss the thing you built the system to find. The only escape is to turn the loop into a conversation. When an astronomer dismisses an alert as a reflection or a cloud artifact, that decision must echo back into the model. When a small number of false positives share a hidden theme, the model must learn that theme and adapt. Without that feedback, the same mistakes will arrive every night forever. Speed matters too, because time is the currency of safety. The best systems do not just flag a candidate. They shoot a note to partner observatories in other longitudes so that someone can look while the object is still visible. A fast handoff can turn a whisper of movement into a solid track in a single night. A slow one can lose the object until next month or forever. Even with perfect machinery, the sky will still trick us. That is why we keep humans in the loop to ask the annoying questions. Does this light curve make physical sense? Does the motion match a jetting comet, or is it more like a tumbling satellite? If the robot is confident but the physics smells wrong, we dig. If the robot is uncertain but the geometry is worrisome, we dig. Judgment is the human edge. The goal is not to worship the algorithm. It is to make a team. Machines handle the flood that would bury us. People catch the outliers the models never met in school. Together they buy the only thing we ever lack in these stories: time to measure, time to update, time to make a calm choice instead of a rushed guess. If we do this well, the robots will keep watch while we sleep, and their alerts will sound less like alarms and more like invitations. Come see, come confirm, come close the loop while the comet is still climbing the dawn. Maps fade when the pens that draw them wear down. Telescopes are those pens. They start sharp. They do not stay that way without care. A mirror that once flashed starlight with crisp precision gathers a film of dust from months of wind and tiny leaks. Each speck scatters light, contrast softens. Faint things that sat a hair above the noise slide back under it and vanish. Detectors age too. High-energy particles smack into the silicon and leave tiny scars. A handful of pixels begin to glow when they should sleep. Others fall silent. The camera still works, but the floor of noise rises and the ceiling of sensitivity drops. If you do not keep careful score, you can mistake slow drift for a calm sky and miss the visitor that was barely there. Even perfect optics can be betrayed by lazy calibration. Every night, a telescope must check itself against known lights. How much does the atmosphere dim the signal tonight? How much extra glow leaks in from city haze and thin cloud? If you reuse yesterday's answer because tonight feels similar, small errors creep into the numbers. Stack those errors for a week, and the trend line bends the wrong way. The faintest comets live in those margins. Pipelines, the software arteries that move images into measurements, grow barnacles as well. A threshold that made sense 5 years ago, before satellite streaks multiplied, now clips away too many pixels that matter. A filter designed to delete airplane flashes accidentally deletes a slow green puff near the horizon. No one notices because the code returns a clean table and the plot looks tidy. Tidy is a lie if it was bought by throwing away the mess that carried the clue. Maintenance costs time, money, and courage. Taking a mirror down for a fresh coat means weeks without data. Replacing a detector means relearning the instrument's personality and accepting a new set of quirks. Rewriting a pipeline means breaking workflows that teams rely on during busy seasons. It is easier to defer long enough, and the instrument becomes a veteran with blurry eyes insisting everything looks fine while the world slips into the fog. The solution is not perfection, it is ritual. Schedule the mirror wash even when the forecast promises the best seeing of the season. Log every new hot pixel and teach the pipeline to dodge them. Treat calibration like science, not housekeeping. Write the why along with the what so that the next team understands the decision instead of guessing. The universe punishes undocumented cleverness. This matters now because late discoveries love the margins. A comet near the sun lives at the edge of glare where contrast is already poor. Add a film on the mirror, and you lose another sliver of dynamic range. Add a handful of hot pixels, and the inner coma looks like snow. Add a lazy threshold, and the faint tail never makes it out of the raw frame. The object has not changed. Our mapmaker has. There is a reward for this unglamorous work. When instruments stay young in spirit, the sky gives up secrets earlier. A faint elongation inside a fuzzy core turns out to be a tiny fragment stepping away. A barely measurable kink in the tail reveals a new jet that models can use to predict a gentle drift. Those are small wins that add up to shorter error bars and quieter nights for the people who keep satellites safe. We cannot stop entropy, but we can slow it with habits that honor the light. Clean glass, fresh code, honest logs, the map stays sharp, the margins stay alive. And the next quiet comet that tries to disappear into the glare will find a watcher with clear eyes and a steady hand. The clock is short, and the checklist is simple. 10 days is enough to turn uncertainty into clarity if everyone does their job. Here is how the story moves from now, through the week, after closest approach, and how you can follow without getting lost in noise. First, daily position updates. Orbit solvers will post new elements every morning as fresh measurements roll in from pre-dawn observing runs. You do not need the math. Watch for the plain language headline that matters. Closest approach distance unchanged within a small range. When that line stays steady day after day, breathe easier. If it shifts, the change should be small and explained by fresh data, not mystery. Smooth nudges are normal for a venting comet. Second, brightness behavior. A single night of dimming or brightening is not a plot twist. Look for patterns that hold for at least 2 nights. A steady rise can simply be geometry. A sudden jump paired with a thicker inner haze could be an outburst that opened new vents. That would not rewrite the distance, but it would raise the odds of fresh dust joining the ribbon along the path. Interesting for modelers. Still boring for ground risk. Third, tail structure. Long exposure images may show the tail kink or sprout fine streamers. That is a window into rotation and where the jets sit on the surface. If the inner tail shows a persistent asymmetry that grows night by night, imagers will try to sharpen the core to search for elongation. The holy grail would be a tiny companion condensation beginning to peel away a few hundred kilometers from the main core. Even then, remember, scale. A fragment that small remains a curiosity for science, not a hazard on this pass. Fourth, coordinated meteor cameras. Around and after closest approach, networks that watch the whole sky at night will compare counts and incoming speeds. A small sustained bump at the expected velocity would suggest that dust from this visitor has thickened one thread of the ribbon. This is most likely weeks after the pretty comet photos fade, not on the actual night of closest approach. If operators whisper about brief satellite slews to reduce cross-section, that will be a footnote, not a crisis. Now for the skywatchers at home, choose mornings with clear horizons. About an hour before sunrise, face east to northeast and scan low with binoculars. Expect a faint cotton puff with the hint of a short tail. City haze will erase it. Dark sights help. If you capture a photo, the most valuable caption is not a dramatic line. It is the context. Date, time, approximate direction, and a quick note on sky conditions. Thin cloud, light pollution, wind, those details turn your image into a tiny piece of the larger map. What not to fear? A viral claim that a brightness surge means an incoming impact. It does not. Brightness is a measure of activity and geometry, not a steering wheel. A rumor that official silence equals danger. In reality, routine safe passes do not generate daily press releases. The work happens in the hallway you met earlier. Numbers update there even when your feed is quiet. The simple ritual for the next 10 days is this. Check one trusted source each morning. Skim the headline distance and uncertainty. Enjoy the occasional fresh image. If a genuine anomaly appears, you will see many independent voices converge on the same observation within a day. If they do not, file the rumor where it belongs and keep your eyes on the dawn. The good ending is the boring one. Closest approach passes with a yawn. The tail fades with the month. The only trace is a handful of honest notes and a few green smudges on cameras that did their best before breakfast. That is not a letdown. That is a win for calm vigilance. Risk feels slippery because numbers do not speak our language. They whisper in ranges and intervals while our hearts ask for yes or no, safe or not. The truth lives between those poles. We can hold it without feeling whiplash if we translate the math into ordinary thought. Begin with the difference between where paths can cross and where objects actually are. The geometric nearest gap between lanes is like saying 2 highways come within a few kilometers at one interchange. That does not mean 2 cars will arrive there at the same minute. Timing rules encounters. This year, the timing is off by a comfortable margin. The comet will be far from us when we pass that interchange. Next, accept that gentle pushes exist. A vent of gas is a tiny thruster that can nudge a light body. Modelers include these nudges because comets breathe, and breathing shifts the path a little. The key word is little. A whisper over days does not move a traveller from a clear lane into a collision without many weeks of evidence. When those nudges happen, you see them in nightly position updates that drift smoothly, not in sudden leaps that defy physics. Uncertainty is not ignorance. It is a box around the best answer we have today. At first, the box is larger because we have fewer points on the map. As measurements accumulate, the box shrinks. The box for this pass is already small enough to rule out impact for the main body. That fact, and the calm routine of updates, are what let you sleep. So, what about the scenarios that keep people awake? A brightness surge, a crooked tail, a rumor of fragments. Each of these can happen without changing the headline. Brightness follows activity and geometry more than danger. Tail kinks trace rotating jets rather than steering wheels. Small fragments, if they exist, drift into a ribbon that Earth might or might not clip months later, as a gentle increase in meteors. None of that belongs in the box marked catastrophe. All of it belongs in the folder called Measure and Note. Here is a way to practice calm thinking. Ask 3 questions in order. How far? How long have we tracked it? How many independent eyes agree on the path? Distance translated into moon units grounds your intuition. Time on target tells you how small the uncertainty box has become. Independent agreement warns you away from single-source drama. If those answers are large, long, and many, the wise response is curiosity without alarm. Probabilities wear human clothes when we narrate them honestly. We can say safe today, still worth watching tomorrow. We can say the miss is large, the error bars are small, and the next update will shrink them further. We can say fragments are possible, and the practical outcome of that possibility is a housekeeping note for satellites, and maybe a few extra meteors for sky watchers. All true, none sensational. This does not mean we shrug at the unknown. It means we let the unknown earn our attention with evidence. When a real anomaly appears, you will see the symptoms line up across communities quickly. Positions that disagree in the same direction, brightness that leaps and stays high, tail structure that changes and keeps the change. Then the tone shifts from calm to focused. Even then, focus does not equal frantic. It equals work. The universe is generous with mystery. We do not honor it by panicking at every shadow. We honor it by checking the numbers, updating the box, and speaking plainly about what changed. That practice is a habit you can carry into every sky story that follows. It turns fear into vigilance and vigilance into sleep. Every big story begins with a person who paid attention when it was inconvenient. In this case, the first clear hint did not come from a giant dome or a government control room. It came from an amateur analyst scrolling through ultraviolet frames on a quiet screen, frame after frame, night after night, looking for a moving smudge that no one had claimed. That patient gaze belongs to Vladimir Bezugi, and his alert is the reason we are talking about this comet at all. Here is the path from hunch to headline in human steps. A watcher notices a faint blob that shifts between successive images from a spacecraft sensor tuned to hydrogen light. 1 dot could be a glitch, 2 dots could be a coincidence. 3 dots that line up with the cadence of orbital motion feel different. He marks the positions, checks for known objects, and shares the suspicion with a small network that knows how to stress test a clue. The tone is not breathless, it is careful. Can anyone else see this? Is the timing right? Did I miss an artifact? On the next clear dawn, small telescopes on the ground swing to the coordinates and fight the glow along the horizon. The view is not cinematic. It is a dim cotton puff that barely pulls away from the background. Yet it is enough. Position confirmed. Motion confirmed. A handful of points become a path you can fit. The discovery now moves into the public ledger, where the quiet machine takes over with orbit solvers and daily updates. Why linger on an amateur's part in a story filled with large instruments? Because this is how real progress looks when systems are healthy. Institutions build the scaffolding that makes the night searchable. Amateurs bring curiosity, stubborn focus, and a freedom to look where schedules rarely point. Each side needs the other. Without the pipeline, there is no ultraviolet map to scan. Without the watcher at the edge, there is no early nudge to wake the pipeline in time. There is also a cultural message here worth saying out loud. Discovery is not a credential, it is a behavior. It is the habit of checking corners that others forgot, and of writing down what you see in a way strangers can test. It is the discipline to invite skepticism before you invite applause. It is the grace to hand the baton to teams who will do the long, unglamorous work of refining the orbit until the error bars shrink to a whisper. Citizen science is not charity. It is force multiplication. 1,000 careful eyes expand coverage in the awkward hours near dawn and dusk when professionals are thin on the ground. A single notebook full of honest logs can reveal a pattern that busy pipelines smoothed away. When the next quiet comet drifts through the glare, the difference between late and early might be one person deciding to check one more sequence before bed. So remember the name attached to the first dots on the chart. Not as a legend, but as a reminder of what matters. Curiosity that shows up, patience that persists, humility that shares. The sky does not care who finds the first pixel. We do, because it teaches us who we can become when wonder meets discipline, and the door to the hallway is open to all who study the light. If the sky keeps hiding surprises in the glare, then we build eyes that love the light. A sunward shield is not armor. It is a network of instruments that stare safely toward the sun, feed clean data to the hallway you met earlier, and speak plainly to everyone who wants to. Follow along. We know the pieces. We need the will to assemble them. Start with vantage points. Spacecraft that live between Earth and the Sun Sit in a sweet perch where the sun fills one side and the inward sky stays in constant view. From there, a camera can watch the cone of invisibility that blinds ground telescopes. Add a second perch trailing Earth in its orbit with a slightly different angle. Parallax from two eyes turns vague smudges into measured positions faster. A third eye from an orbit tilted above the plane of the planets peeks over the glare where long-period comets love to hide. Geometry beats mystery. Next, diversify the colors of light we watch. Hydrogen ultraviolet is a proven beacon for comets. Keep it. Add near-infrared channels that see warm dust streaming away from fresh vents. Add visible bands with smart coronagraphs that block the blinding disk and reveal the field around it. Each band finds a different clue. Together they pull a ghost into view days sooner. Now, shrink the hardware. A handful of small satellites can fly the same playbook, once reserved for bus-sized observatories. A compact ultraviolet mapper, a coronagraph, and a modest wide-field visible camera can ride separate rideshares and stitch their results in the cloud. If one fails, the network limps and learns. If all fly, the net tightens around the blind spot. Data matters as much as glass. We need pipelines built for speed and clarity. That means nightly products in human language alongside the technical feeds. Path updated, misdistance unchanged, uncertainty narrower by a small step. It also means a public dashboard that anyone can scan in a minute at breakfast. No jargon, clean plots. Map views that show where the newcomer sits relative to Earth and the Sun, with the clock ticking in the corner. A community that can see the sausage being made is a community that trusts the kitchen. Coordination is the force multiplier. When a sunward watcher flags a candidate, the alert should make a fast lap around the world in minutes, not days. A partner in the opposite hemisphere points a ground telescope at the same coordinates during its dawn and returns a confirmation. A radar team checks geometry and posts a quick yes or no for a ping. Meteor networks add a watch note for expected speeds weeks later if dust seems likely. The script is simple when the doors between rooms stay open. We also need to fund the unglamorous habits that keep the shield sharp. Regular calibration, public logs of instrument health, and versioned code for the pipelines that anyone can inspect. When thresholds change, explain why in plain language. When a sensor grows noisy, show the trend. Sunward work already asks people to trust eyes they cannot see. Meeting that trust with visible discipline is part of the job. Finally, invite the edge. The same amateur spirit that found this comet can live inside the shield. Publish a small stream of downsampled frames and a how-to page that teaches motivated viewers what motion looks like near the Sunday. Host weekly office hours, where engineers and scientists answer a dozen focused questions from the public. The reward is a larger, more patient watch crew, and the occasional early nudge that saves a precious day. A sunward shield is not a single satellite or a single app. It is a posture. It says the universe will keep playing the same trick, and we will keep learning the counter, eyes in the right places, colors that carry different clues, software that respects both speed and sense, doors that stay open between professionals and the people who care enough to look up. Build that, and the next quiet comet that tries to slip through the light will find us already waiting. Put the sky's two archetypes side by side. On one hand, a well-known asteroid the size of a city block glides toward a close, safe pass a few years from now, tracked for decades with exquisite precision. On the other, a crumbly long period, comet slips out of the sun's glare with only weeks of data and a habit of coughing dust. Same cosmos, very different headaches. The predictable giant teaches the comfort of time. Decades of positions turn a dotted line into a rail. Radar has painted its shape and spin. Tiny tugs from sunlight can be measured and modelled, because there are so many nights to compare. Missed distance is not a guess. It is a number with small error bars that shrink again each time fresh measurements arrive. With that confidence, teams plan campaigns like a festival. Telescopes book windows. Spacecraft line up experiments. Teachers prepare sky days. Everyone wins because the clock runs slow. The unpredictable stranger teaches the cost of surprise. We met it after its hottest moment near the Sunday. We missed the chapter when vents first woke, when cracks first opened, when a small piece might have peeled away and started to walk. The orbital fit is fine for safety, but thin for behavior. A sudden brightening here, a shifting tail there, and the models must bend around fresh evidence. No alarm, yet no luxury of long arcs either. The clock runs fast. Here is the lesson in plain words. Size is not the only axis that matters. Predictability is a superpower. A big, famous rock with 20 years of data can be less troubling than a small, fragile visitor with 20 days of data and a talent for outbursts. We are not comparing danger, we are comparing workload. The giant demands precision, the stranger demands agility. The contrast also clarifies what to build. For the big knowns, you want endurance. Instruments that last, radars that can ping, and analysis pipelines that keep their memory intact across generations. For the small unknowns, you want rapid discovery near the sun, quick handoffs across longitudes, and public dashboards that let everyone see the orbit settle in real time. The first is an observatory marathon. The second is a relay sprint. There is something hopeful in this pairing. The giant reminds us that patient, cumulative science tames uncertainty. The stranger reminds us that humility and flexibility keep us honest when the universe throws a curve. Together, they argue for a culture that does both at once. Invest in the slow work that makes future surprises rarer. Invest in the fast work that makes the surprises we cannot prevent less dramatic. So when you hear the countdown to a famous flyby in the next few years, enjoy the certainty. It was earned one careful night at a time. And when a quiet cotton puff appears near dawn with a green breath and a shifting tail, do not assume the worst. Assume the work, measure, update, share. The more we practice both modes, the less the sky can rattle us. The predictable giant and the unpredictable stranger are not rivals, they are teachers. One teaches how far rigor can carry us when time is generous. The other teaches how far teamwork can carry us when time is not. Hold both lessons, and the next test, whatever shape it takes, will feel less like fate and more like a problem we are ready to solve. The sky is busy, but most of it is friendly. Lights drift, dust burns, shadows pass. We do not need fear to stay awake. We need attention, clear eyes, steady hands, a willingness to ask simple questions every morning and accept unglamorous answers most nights. Here is the heart of it. We found a comet late because it hid in the brightest part of our view. We caught it anyway because someone looked where others could not, and because a spacecraft watched in a color our eyes never will. The numbers say large miss. The behavior says stay curious. Both can be true at once. That is not a contradiction. That is how grown-up science sounds. Over the next days you will hear claims and counterclaims. A photograph will go viral because the tail looked longer, under thin cloud. A thread will insist that an outburst means a steering wheel has appeared in space. Breathe. Brightness is not a vote. On danger. Tail shape is a weather report written in dust. The orbit is set by gravity with tiny nudges that the math already expects. When something real changes, you will not need a single screenshot to believe it. You will see many independent observers, in many languages, report the same shift with the same numbers. Consensus is not magic. It is how reality leaves footprints. Vigilance without panic looks like ritual. Measure before dawn, post the positions, update the corridor. Note the brightness with the simplest words you can speak. Clear, hazy, thin cloud. Then do it again tomorrow. If a fragment appears, write it down. If meteor cameras whisper that the counts ticked up a little at the expected speed, write that down too. The record is not a museum label for the curious. It is the spine that holds our shared memory straight when rumor tries to bend it. This approach is not cold. It is humane. Panic burns people out. Vigilance builds communities. Amateur observers who keep honest logs are teammates. Students who write code that cleans a noisy image are teammates. Engineers who scrub a mirror on a Tuesday while the wind howls are teammates. A culture that thanks steady work as loudly as it celebrates a spectacular photo is the culture that will notice the next quiet visitor in time. There is a deeper choice under all of this. We can be spectators waiting to be surprised, or we can be guardians who expect surprise and prepare for it. Guardians do not shout, they share. They design instruments that stare into glare. They write pipelines that speak to humans in plain sentences. They keep the doors open between rooms so that a hint in ultraviolet can call a telescope in Chile before dawn and a camera in Arizona before dusk. They understand that the sky is a relay race and that the baton must move quickly and cleanly or not at all. If you want a simple rule to carry forward, keep this one. Celebrate when the ending is boring. Boring means the orbit behaved. Boring means the hallway of quiet work did its job. Boring means satellites kept humming, astronauts slept, and the only fireworks were meteors lighting their thin paths through the upper air. Boring is a triumph dressed without sequins. Soon this comet will fade into the file of near misses and instructive nights. Another story will rise. It might be a different comet. It might be an asteroid with an angle we did not expect. It might be a faint whisper at the edge of a detector that turns out to be nothing at all. The method does not change. Measure, model, update, repeat. When a true test arrives, we will already be in motion, and motion is what separates guessing from knowing. Keep your eyes on the dawn, keep your questions simple, and your standards high. Wonder belongs here. Alarm does not. We are not the heroes of the sky. We are its careful readers. Read well, and the universe will keep giving us stories worth telling without ever taking our sleep.